Yes, we'll start this video. This video will be on completing numerical integration using the R Studio and the various applications, various functions inbuilt with R Studio. We move on to this idea of integrating functions numerically using R Studio. Some of the functions can be computed directly by using the inbuilt functions. For example, the gamma function can work using the keyword gamma available in R. I have written the code to find the gamma of 4. The gamma of 4 can be found as 6 as available in the screen. And then I can also use the inbuilt function tan of pi by 4 to calculate its value. The code just involves the keyword tan. Tan of pi by 4 will return the answer 1 as seen in the screen here. We can also perform integration of functions, integration with limits by using numerical approximation. This is done using the keyword integrate. The syntax for this for using this keyword is that the function and its lower and upper limits must be clearly mentioned. As we can see in line number 22, integrate, the function integrate takes in three arguments. One, the function. Two, the lower limit, which is defined by the equation lower is equal to 0. And three, the upper limit, which is defined by the equation upper is equal to 4. Running this chunk will return the output where the answer is printed as 64 with absolute error 7.1 e to the power of minus 13. This answer is a result of numerical approximation, and the 7.1 e to the power of minus 13 tells us that the error is 7.1 times 10 to the power of minus 13. If you would like to get rid of this absolute error and return only the actual answer, we can use the command result hyphen dollar value. This command uh, helps us return only the exact answer, which is 64, printed on the next line. And then the next example I've taken up to define the integral of sine of x between the limit 0 and pi. As usual, the answer is 2, but it is written with an absolute error, which is 2.2 times 10 to the power of minus 14. The error is very negligible. But still, like the previous problem, if you would like to, get only the exact answer, you can use the dollar value command. I wanted to emphasize that truncation function will not work here. The one which we saw in the previous exercise, that will not work here. Instead, you can write the answer as print of result dollar value. If you run this chunk, then the result will be simply 2 without the absolute error part. So you'll get the answer only as 2. In the last example, I've discussed the function to evaluate double integral of a function, a multivariable function in x and y. To use this function, we need to install the pragma package. As usual, I'll first click this button, which opens a pop-up window where we type the name of the package pragma and ask to install. As long as there is a stable Wi-Fi connection, this package can be installed. Once I have installed the package, I can check that it is carefully installed by typing it in the search box here. It shows that the package of Pragma is installed. Once we have installed the Pragma package, we call it as in line number 38, and then we use the DVL quad function, double quad function, which takes as input the function, the lower limit in x, the lower limit in y, and the upper limit x and the upper limit y, and returns the answer as well. So in this video, we have learned how to integrate numerically and how to calculate the gamma of a function and how to get rid of the absolute error in the answer by using the absolute the dollar value keyword here. Once we have done this, we can paste all the output, we can print all the output to a Word document, and we can complete this exercise. So what I'll do is I'll save this as a markdown file, and once I've done that, I can ask for it to be knit to the Word document. The command will return a Word document which will have this coding as well as the output as the answer. So in the